A very warm welcome to all my brilliant SS3 students. This is your go-to series for smashing physics in your WAEC, NECO, and JAMB exams. Today, we are jumping into a topic that is an absolute favorite for examiners, the refraction of light. Trust me, by the time we are done, you'll be able to solve any question they throw at you on this. Let's get right into it. So here's our game plan. We'll kick things off with what refraction is all about. Then we'll dive into the laws and principles, the rules of the game. After that, we'll check out lenses. And then, the best part, we'll tackle some real past questions. This whole structure is built to cover everything you need straight from the syllabus. Okay, so why are we dedicating a whole session to refraction? It's simple. This topic is a high scorer. It's a gold mine for marks. Examiners love it because it lets them test you on both theory and calculations. If you can master this topic, I guarantee you've just secured a whole bunch of marks for yourself. And look, just so you know we're not playing around, everything we're about to cover is pulled directly from your official syllabus. We're talking the meaning of refraction, Snell's law, refractive index, apparent depth, that special thing called critical angle, and of course, lenses. This means you can relax and be confident that you are learning exactly what you need to pass. All right, it's time to build our foundation. We are now getting into the real heart of the matter, the laws and principles that explain how light bends. So I need your full attention here because this is where it all begins. So what is this big word, refraction? In simple English, it's just the bending of light. That's it. Think about a ray of light traveling happily through the air, and then suddenly it hits a block of glass or a pool of water. Now water is denser than air, so light slows down, and because it slows down, it bends. It's the exact same reason why a straw in a cup of water looks like it's broken at the surface. Yes, that's refraction in action. Now, there are two main laws that control this bending. The first law is pretty straightforward. It just says that the incoming light ray, the bent ray, and the normal, that's just an imaginary line we draw at 90 degrees of the surface, they all lie flat on the same surface. But the second law, that's the superstar. That's the one that helps us with all our calculations, and it's called Snell's law. And here is the master formula for refraction. You have to know this formula like the back of your hand. N equals sine I over sine R. Here, I is your angle of incidence, R is your angle of refraction. And that N, well, that's the special constant we were talking about. We call it the refractive index. So what exactly is this refractive index N? Well, it's just a number that tells us how much power a medium has to bend light. The bigger the N, the more the light bends. But here's a secret examiners love. N is also about speed. The refractive index is simply the speed of light in a vacuum divided by the speed of light in that substance. JAMB loves to ask questions using this version of the formula, so take note. Let's talk about something you've definitely seen before. You know when you look into a swimming pool and it looks way shallower than it actually is? That's an effect of refraction we call apparent depth. The light coming from the bottom of the pool bends as it comes out of the water, and it tricks our eyes. The formula for this is super easy. Refractive index N equals the real depth divided by the apparent depth. Okay. Now for something really cool. Total internal reflection, or TIR. For this magic to happen, two conditions must be met. Number one, light has to be going from a dense place to a less dense place, like from inside glass out into the air. Number two, the angle it hits the surface must be bigger than something called a critical angle. If you hit the surface at an angle bigger than this critical angle, the light doesn't escape at all. It gets trapped and reflects back inside. This isn't just textbook stuff. This is the principle that makes the internet work through fiber optic cables. All right, so let's move on to one of the biggest real-world uses of refraction: lenses. I can tell you for a fact that this section is a big deal for your exams. They love to ask about lenses because they are everywhere, from our own eyes to cameras to glasses. You really only need to know two main types. First, we have the convex lens. This is the one that is fat in the middle. Its job is to gather up parallel light rays and bring them all together to a single point. You know, like a magnifying glass. Then you have the concave lens. This one is thin in the middle and it does the opposite. It takes parallel rays and spreads them all out. Now for the calculations. These two formulas are your best friends when it comes to lenses. The lens formula connects the focal length, the image distance v, and the object distance u. Then the magnification formula tells you how much bigger or smaller the image is. Just a quick warning, always be careful with your signs. We are using the real is positive convention here. Okay, theory class is over. Now for the part that really matters, using what we've learned to get marks. We are going to solve actual past questions from WAEC and JAMB. This is where you see exactly how these ideas are tested in the exam hall. Let's do this. Here we go. A real WAEC question from 2005. It's a classic. They give you the angle of incidence, 30 degrees. They give you the refractive index of glass, 1.50. And they ask for the angle of deviation. Don't let that word scare you. It just means how much the light ray has been bent away from its original straight path. Let's solve it together, step by step. First, what do we need? We need the angle of refraction, r. So we use our master formula, Snell's law. We rearrange it to make sin r the subject. So, sin r equals sin I divided by n. We plug in our numbers, sin 30 divided by 1.5. That gives us an angle r of about 19.47 degrees. Are we done? No. The question asked for deviation, d. Deviation is just the big angle minus the small angle. So I minus r. That's 30 minus 19.47, which gives us our final answer, 10.53 degrees. See? Not so hard. Now, let's look at a typical JAMB style question. JAMB just loves these two-step problems. They give you the speed of light in air and glass and the angle of refraction. Then they ask for the sine of the angle of incidence. Did you catch that? They didn't ask for the angle. They asked for the sine of the angle. You have to read the questions carefully in JAMB. So how do we attack this one? It's a two-step knockout. Step 1, we need the refractive index. They didn't give it to us, but they gave us the speeds. So we use our speed formula. N equals speed in air divided by speed in glass. That's 3 times 10 to the power of 8 divided by 2 times 10 to the power of 8. The 10 to the power of 8 cancels out, and we get N equals 1.5. Beautiful. Step 2. Now we use Snell's law. We need sin I, so we rearrange the formula. Sin I equals N times sin R. That's 1.5 times sin 30. Sin 30 is 0.5, so 1.5 times 0.5 gives us 0.75. And that is option D. Done. Fantastic job, everyone. We've gone through all the theory and we've solved some real exam questions. Now let's wrap it all up with a quick summary and some killer exam tips that will make sure you don't lose any cheap marks. Okay, get your phone or your notepad ready. You need to screenshot this slide or write it down. This table has every single important formula we've discussed today. This is your personal cheat sheet for refraction. Before you walk into that exam, make sure these formulas are locked in your brain. And here are my final words of wisdom. For WAEC theory, please always draw your diagrams. They carry marks, and show your workings, formula, substitution, answer with units. And for the love of physics, make sure your calculator is in degree mode. For JAMB, double-check what the question is asking for before you pick an answer. And for both exams, memorize your definitions. There are free marks just waiting for you to collect them. So after everything we've covered today, you have the knowledge, you have the formulas, you have the strategy, you are more than ready. Believe in yourself, keep on practicing, and I promise you, you will walk into that exam hall and tackle any refraction question with 100% confidence. You can absolutely do this. If you found this lesson helpful, please do me a quick favor. Hit that like button. Share this with all your classmates and friends who are also preparing for WAEC, NECO, and JAMB. And most importantly, subscribe to our channel